Hello guys, I'm Yabing. Welcome back. In this video, we will discuss the second part of the ADAS system, the practice, and we will start with the CAN communication. So firstly, open Matlab and create a blank Simulink model, as I did here. And what we need for CAN communication is, open the library. There is a toolbox named Vehicle Network Toolbox and CAN communication. So we need firstly to configure the CAN. So we need a configure block. So before we can send the signal out, we need to pack the signal. So CAN pack block. Pack all signal into the message frame. So after packing, we can transmit them out. So CAN transmit block. And by the receiver parts, we need firstly a block to receive all the message. Then after receiving, we need to unpack the message to get all the signals. So this is the 5 block we need at present. Basically, first step is to configure the CAN. Second step, to pack the signal into the frames. Then transmit the frame out. Then by the receiver part, receive all the message. Then unpack the message to get the signals. Totally 5 steps. Now we have all the blocks here, and how can we combine them together and make them work? As mentioned before in the theoretical parts, we need a database, also a DBC file to connect them, combine them all together to make them work. There is no such app in Matlab Simulink to create the DBC file, but don't worry, we got free one. This one, Vector CAN DB. You can easily download it from the Vector homepage. Now I will create a simple database to show you how they work. So create database. You can choose either we just use the standard template. Standard templates. Okay. So just name it. While we just give it a name. Give it a name. Okay. Let's try firstly with a simple communication between two nodes. So let's say a camera and a controller. So new add a camera. Camera, apply yes. And first node, we need a second node, controller. Controller, apply yes. Then the frame. Let's assume that the camera detects something and then send its coordinates out. So we need a message to store the coordinates. So detection, let's say first detection, and it's a message. Apply. And then signal. The coordinates consist of 2 elements, x and y. So let us say detection 1 x, and it's a signal. Copy it. Okay. Then second signal for the y. Okay, apply. Now we have the nodes, the message, and the signal. Now we put it together. So firstly, put the signal inside the message. Signals. Yes, and then put the message into the camera on and controller. So by the camera is sending this message out. So add the message. Okay, apply yes. Then controller is receiving the signals, receiving the message. So map receiving signals. Okay, then this DBC file is done. We will put this DBC into our Simulink model. And choose the device. By default setting, the Simulink contains 2 channels, but they are only for internal simulation. If you want to grab the signal out for your real hardware test, you can install your own device, such as what I did here. I've installed 2 vector channel. Just download all these drivers from vector homepage. Here we only do the internal simulation, so choose the channel 1. Other setting, just leave it default. So we configure the other 4 blocks. Put it in the right order. Oh, first, let's do unpack. So CAMPACK data source is we have created a database. So choose this one and then add in the database we just create, this one, and then choose the message. Only one here. Apply. Okay, and then transmit. Choose the channel as we configured by the configure block, and we want to transmit then periodically. The time, the standard CAN frame time is 10 milliseconds, so 0.1 seconds. Okay. For the receive parts, do the same. It will change automatically. And for the unpack part, the same. And which message to unpack? Firstly add in the database. Then choose the message to unpack. Apply. Okay. Then you got out these 2 signals out. Now we combine it together. Yeah, for the input, we just use 2 constants instead to show how they work. And then say 5. I guess it's 5. And y give it 7. Okay. Then image coming out here, and the image is coming out here. You might notice that there are 2 outputs from this receiving block. This function number is a trigger function, which means the downstream blocks can avoid all time running, but run in a trigger model. Only when a CAN message is received, then trigger the downstream blocks. So to do so, we need to make this into a subsystem. Yeah, create subsystem, and then inside this subsystem, we need to add a trigger. And change it into function call. Apply out. Then come back. You will see here the trigger here. Add combine here. So now we use to display to show the display the outputs. Combine here. Okay, combine here. So that's all the configuration. Now we can run it to see if these 2 signals has been transmitted to here through the CAN bars. See, it's work. 5 7 5 7. Try to change to, let's say, 3. Okay, run again. Yeah, 3. If you want to check inside the CAN bars, there is a tool for it. CAN tool. So this, in this window, you can see all the CAN messages. Let's see. Let's try to run again. First, open this, then run here. See, there's all the messages here. 5, this is the data 53 and 2 bytes. Let's see, to 9. Okay, run again. See, they change now. Yeah, that's basically the CAN communication. A simple example, and for our later discussion, I have created another database. I'll show you now. We don't have to save this. So have a look at this. So for our project, I have created another database, another DBC file, and totally 3 nodes: controller, driver, and scenario. The scenario is the sensor, and for the environmental detecting, and the controller is for calculation, and driver is for execution. So the message, one control message for the left side driver and one for the right side driver. And these 2 messages will be sent out by the controller and received by the driver. In totally 9 detections. The detections will be sent out by the scenario and received by the controller. And the signal here, we will take all the coordinates from all 9 detections, x, y for each. Okay, now let's discuss the first element of the ADB system, the environment detection, also the sensor. So in Matlab, there is an app for this kind of simulations, the driving scenario designer. With this app, you can create any driving scenario you like. So let's open it. So here in the automotive, driving scenario designer. So let's try add a row on it. So you can change the parameters here. Let's say there's 2 lanes. What happened? 1 second. Say it's a 2 lanes, and you can change the parameters as well as here. Let's change the color of the mark lights. Change it. This is the RGB color. Each element varies from 0 to 1. Let's say 0.1. See what we got. Okay, we got yellow. Change to solid. Oh, now the second change to solid. Change to solid. Yeah. And okay, this is the low. Now we can add a car. The first car is always the equal car, the origin of the whole system. So right click to add some waypoints. Its trajectory. How should it move? And here you can change the speed of each waypoint. Run. This is the view from the car. And now let's add a car for being tested by our ego car. To put it here, and also add some waypoints. Okay, let's see. Okay, for detection, we still need a sensor. So it can be a camera or radar. And this scenario, they are the same. So, okay, let's say try to add a radar here and put it here. It is here. The placement just leave it in default, and we change it here. Let's say this is the detection angle. Try to 90. And the max range, okay, just to show the effects, we 40. Okay, you can see here. Now we in this bird's eye plot, we can see the detection, how it works. Let's go around. You can see this auto is detected here. And go star. Post here. So these points are the detection results and will be sent out. So we have created this scenario, and how can we export it and use it in our Simulink model? Yeah, here export and export Simulink model. There are also other options, but here we use this one. It might take a while. So this is the scenario reader. This one will read in the scenario we just create, and the radar will work on the scenario and detect object and give the output. Okay, just leave in default. Also, we can check the signal here. Also in this environment, use the bird's eye scope. It will find the signal automatically. And if you run it, they are exact the same. Yeah, it's a little bit faster just because of the updating speed. So this is the scenario, and this is just a simple one. For our project, I have created another one. Okay, let's open it. See this. And this one is a little bit more complicated. See, these two cars are detected. Yeah, it's quite slowly here because I've made it slow in this way. Later we will see in detail in the whole system. So much for the detection part. The CAN communication and the scenario detection. Now we discuss a little bit about the controller. As we mentioned before, the controller will take the data from the sensor and then calculate the motion plan for the driver. Here is the basic algorithm for the controller. Here, the lighting area is divided into 12 parts. The left headlamp will cover the 6 parts in the left, and the right lamp cover the 6 in the right. Actually, in this example, these parts in the corner will not be covered by the sensor or by the lights. I just put it in this way, just made it easier to understand and to program. So just put it in this way. You can also see from the DBC file, totally 12 control signals for controlling of each part. So left down 1, left down 2, left up, right downside, right upside. Totally 12 signals. Objects show up in the light in one of the lighting area, and the LED will be turned off. And for the driver, we will just use a set of PWM generators instead. So now later we will have a look at the whole system. Okay, now let's have a look at the whole system we just created. And it consists of 3 parts: the sensor, also driving scenario, and the controller, and the driver. So in the scenario, let's open it. So yep, you have seen this before. So the scenario reader read in the scenario, and the radar here. One parameter we have changed here is here the DPC file. Yeah, here. In the DPC file, we have created 9 messages for 9 detections. So that's the reason why, because we set here to 9 detections. So the scenario will output the detection, and the detection will be shipped out with a data bus. It's just a bunch of signals being sent together. So before the data can be transmitted through CAN, we need to extract them. Out. So the output of the scenario contains many data, and they have to be sent one by one. So first we use a bus selector to select out the signal from the bus. As you can see here, yeah, you can see from this selector, the output of the scenario contains many data, and what we need here is the number of detections and the detection itself. As mentioned before, there are totally 9 detections, so we need to split them. Use the selector. So dimension is 9. Here is the first. Take out the first one. Oh. And here, take out the second one, and so on and so forth. So on and so forth. The last one is the nice one. But each detection is also a subbus, so we need another bus selector select out the signals from the detection. It's called time measurements and sensor index, many others. And what we need here is the measurements. So the measurements contain many data, and the first 2 elements are the coordinates x and y. So we use a vector selector, another selector to select out the first and second elements. So here take out the first one, and here take out the second one, also the coordinates x and y. Do the same to other 9 detections. Next step is to pack these signals into message frame, then transmit. So each message frame has to be packed individually. And yeah, just choose the database we create and which message to pack. Do the same to all the messages, one by one. Do the same to all. And then use a vector concatenate to to put all these vectors together and transmit, use the CAN transmit block to transmit them out and put them on this channel. So till here, we have finished the scenario part, and this scenario will detect environments and put the detection coordinates onto the CAN bus. And in the controller part, the controller will receive the CAN message sent from the sensor, and this receiver here will take the message from this channel and unpacks the message one by one to take out the signals. Here we unpack just the other way around of the packing. Unpack the message and then take out the signal. So till here we get all the signal out. And this signal will be the input of the controller, this block here. We will calculate the motion plan for the driver. Here I just do it in a very simple way just to check which area is the detection located. Then send out the commands to turn on, turn off an LED. This is the input of all detection coordinates, and then output the command to turn on, turn off the LED. Very simple algorithm. And then next step is to send to pack all this signal into a message and then send out the message. And the driver part, it will firstly receive all the message from it will receive all the message and then unpack those with an unpack block to get all the command out, and then send this command into the element generator to create the PWM to control the LED on or off. So this is basically the whole system. We can run it and have a look. It may take a while to compile. And since data changing, to compare, first we open the driving scenario to compare if it's right. Signal. Yep. So let's run again. Okay, we start here. Oh, no, continue. Okay, we start here. See, these two cars are detected and it will locate in the left side and mostly the upper side of the left. So you can see, so compared to here, totally this six part is for the left and 6 for the right. So left up, so 0. These two LED are turned off. So we got the right data and continue. And here we can see from the right side, the right up side, one LED show off because there's a car here. See, this one's off. So basically it's working this way. So continue. And again, for the diagnose purpose, we can open the CAN tools again. So run again. Yeah. So you can see the data is updating here. So that is all about this topic, and hope you enjoyed it, and see you in next topic. Thank you.